Welcome to this video session. I will now show you how to create a reverse TCP shell from one machine to another machine. We probably know how to create a shell from a local machine by just typing in commands like bin bash or something equivalent. Now I will show you how to redirect that shell from a local machine to a remote machine. What you are seeing here is a simple virtual machine, and I have two terminals. One is named attacker, another is named server. This is attacker, this is attacker, and this is server, right? And I'm going to create a simple bash shell on the server machine, but I will redirect the shell to the client machine. Client in this case is the attacker. Okay, let's get started. How do we do that? So first of all, we need to know a few things. We need to know the IP address of the attacker's machine. So how do we get that first? If config will give us the IP address. What is the IP address? One moment. Yeah. So this is the IP address of the attacker's machine. Okay. And now we will redirect the socket to that machine. One moment. So I'll clear the screen just to be clear. What I want to do is start the listening socket, which is basically using the netcat. Netcat is going to listen for connection back from the server to the client. Okay, so the attacker is just starting the netcat, which is a standard Unix command. So now it's listening for connection at port number 9090. Now let's switch to the server machine. I'm not showing you how the attacker got into the server at this point, but let's assume the server is already compromised for a moment. Okay, so now all we have to do is create a bash, right? Bash, which is the regular bash command. But then we wanted to run it interactively, so -i is for interaction. We wanted to redirect that output into a TCP socket. Okay, that's where the TCP socket business comes into play. So how do we redirect this? We just put dev /TCP, and then we need to now paste the IP address of the attacker. So this is the IP address of the attacker, to be clear. Okay, and we have to put the port number also. Okay, this part should be fairly easy because this is basically redirecting an output of bash command into a socket. All right, but what about the inputs? The inputs are going to be coming from the attacker, so the attacker should be typing commands on this side of the window, and we expect the command to come here. And after running the command, we want the output also go back to the attacker. Okay, that is already taken care. The output is taken care by the redirection. What about the input? So the input can be a little confusing. So let me clarify that. In Unix, we have 0, 1, 2 as the number that identifies standard input, standard output, and standard error. So let me clarify that first. So we need, let me just write this notation here. 0 means standard in, 1 means standard out, 2 means standard error. Okay, and we will use this to redirect. Okay, what is the meaning of this? Let's think about this for a moment. What is number 2? Number 2, oh, one moment. Number 1. What is number 1? Number 1 is standard output, right? But where is the standard output currently pointing to? The standard output has been redirected to the socket, right? That's the meaning of this first greater than symbol. So what does this tell us? It tells us that the input to the bash shell is basically this number 0, right? That's the standard in. Where do we get the input from? We are getting the input from the standard output, which is very confusing. The standard output is actually nothing but the TCP socket, right? The TCP socket is the standard output. Okay, that means the program is going to take data from the socket. And now we also wanted to handle the special case. Suppose there is some error happening. Okay, we don't know. Maybe there is some error. The client was sending a wrong command, then the bash will produce an error message, right? We need to redirect the error also. So what we're going to do now is we take the number 2, which is the standard error. We redirect it to what? To number. What number should we do? To number 1, right? Because 1 is the standard output, right? This is number 1, standard output. And where do we have one pointing to already? One is already pointing to the socket. Okay, so if any mistake happens on the server side, the client is going to be able to see that because of this little trick we did here. Okay, so now we are ready to press the enter, and what you see here is that listening, and we have a connection. And if you look at the connection, it says there's a connection coming from this machine and it's accepted. Of course, if you pay close attention, you see the terminal has a different name now. The command prompt has a different name than the name we have started with. So whose command prompt is this? This is nothing but the command prompt of the server. I just changed the prompt before the demo, but this is the command prompt of the server. If we type some things here, ls, we are talking about listing all the files on the server. So we get all the files on the server. Let's do something. Suppose we do exit. Okay, what do we expect to do? Usually when we press exit in a terminal, the terminal will go away, right? This terminal will go away, but it's not. You see here, it's saying exit, exit, because as you can see here now, the shell prompt is back. The exit command was executed on the server side. The server executed the exit command and got out of the bash prompt. As you can see, there's no hidden shell here. The shell is closed essentially. So let me try to summarize this, what we have done so far. First step is to find out the IP address of the client machine. That's the attacker's machine. Okay. Step 1, IP address of the attacker's machine, right? You need to know that, otherwise you can't make the reverse shell. What did we do? Step 2, start netcat -L 9090 in a verbose mode if you want. The -V is for verbose, not necessary, but you can have it. Now on the server side, we need to do something here. We type this command bash, right? And then we redirect that. -I stands for interactive. We redirect that into dev TCP and then the IP address of what? Of attacker's machine. Okay, attacker. Okay, and then we need to just redirect the output instead. That's all. The shell needs input. Where will the shell get the input from? 0 stands for standard input. We are saying go and read it from the standard output, which is nothing but 1. But standard output is nothing but the socket, because we said redirect the standard output to the socket. Okay, this is a little bit confusing part, but essentially we are saying read from the socket and write to the socket. That's what we are trying to say. And now if something goes wrong, standard error will also be redirected to the standard output. That's all. That's the command we need to run on the server side. Attacker will now get a prompt on his machine, which is nothing but the prompt he would have gotten if he is physically on the server. That's basically how we create the reverse shell from one machine to another machine. That's all I want to show you, how to have a reverse shell. It's very easy, as you can see. Okay, thank you very much.